The CSMC is a huge milestone to get us to SPARC. This test is a significant scientific milestone for CFS because it really establishes the feasibility of this technology. So when we set out to do the CSMC, which was actually the beginning of CFS, we always knew that we wanted to use the HTS technology to make our toroidal field magnets. And so those are the magnets that are always on. There are also these pulsed magnets, and one of the hardest pulsed magnets is called the Central Solenoid that drives a current in the plasma. So just like we had a toroidal field model coil, or TFMC, we conceived of a Central Solenoid Model Coil, the CSMC, that would basically adapt the technology that we had developed for the TFMC and turn it into something that you could run a pulsed magnet coil with. The CSMC is the largest pulsed HTS coil ever built.
If you look at the CSMC from a systems basis, you'll see hundreds of systems coming together, from cryogenics to power supplies to each of the unit cells and subsystems within the magnet itself. It's been 4 years of work to get all of those systems up to speed, and this culmination was an incredible example of what all of those pieces can do when they're working in harmony together. I think a huge part of what made the CSMC so successful was the collaboration and integration of our teams at CFS and MIT. Everything was heavily integrated between those two groups. We couldn't have done it without them. They couldn't have done it without us.
This is, from beginning to end, a new technology. We started 4 years ago with just a piece of superconductor, turned it into a cable, mass-produced it into several hundreds of meters, and now we built a magnet with this technology.
For the testing of the CSMC, it wasn't just turning it on and see does it work. We actually went above and beyond the conditions that this should see in SPARC. So the first test of the CSMC was really just showing that it would work in normal operation. So we stepped it up through a series of currents up to its final operating current of about 50,000 amps. That's a lot of amps. But then, because it's a test article, we also put it through its paces in a whole bunch of different ways. And so one of the big things that we tested in this coil was in the protection system.
So one of the most innovating things about our cable technology is that it uses fiber optic sensors to detect hotspots. Any superconducting magnet stores a lot of energy. And if that energy suddenly transforms into heat, it can burn and destroy the magnet. We use fiber optic sensors to detect hotspots in our magnet to effectively protect it from itself. After the first test campaign was complete, we warmed up the magnet, we cooled it back down, and then we repeat the process. The goal was to see if the magnet not only survived, but also performed exactly as it was at the beginning. And it did. It did not degrade. It was as good as new at the end of the test.
The CSMC test has kind of blown away all of our expectations. What that means is that it's laid a really strong foundation for the cable magnets within SPARC.
Now that the CSMC is done, we're ready to start integrating full cable-based coils out of our magnet factory. If you think about the CSMC going from 0 to 1, where you're really proving out the technology, the next step is going from 1 to thousands.